And yeah, first off, apologies. I haven't shared the midterm feedback yet. I've been super busy at the beginning of this week and thought I would get to it on Friday, which didn't happen, and then haven't had a chance to do that since then. So I will try, if I can do that, to share it in Slack at some point today or possibly tomorrow. I would like for you to be able to see what other people are saying about how things are going in the course. And of course, for my own personal interest, it's nice to have your feedback to know about things that can be improved in the way the course is run and the way that we sort of use various learning technology in the course to try to help you to not only gain some understanding about using Python as a programming language, but also some common tools that are used by people who do this kind of programming for their job. But yeah, starting first with the feedback that's here so far today, just looks like only 2 comments at this point. One about the sort of pandas syntax and some slight problems with that. Very much understandable. Pandas is fairly flexible and diverse library that can do a whole bunch of different things. And so if any of you have ever used software like QGIS or ArcGIS, maybe you've experienced somewhat similar things. That sometimes it's hard to remember exactly what to do because there's so many options for how you can interact with your data. And Pandas is a little bit like that. While you're first getting used to it, it just takes a bit of time to remember how to do various things and to remember the syntax to use. Perhaps most notably when sort of making the distinction between what we've done earlier in the course, which was use parentheses when we were using functions. And whenever we were either defining or calling a function, we were using parentheses. And then we were always using the square brackets to refer to index values. And in Pandas, it might feel a little bit like those things are being mixed in a way that doesn't line up with what we've seen earlier. And I'm not entirely sure. I may have just convinced myself that it does kind of make sense, but I'm not a sort of Pandas guru. But one thing to think about is that some of these things like loc, iloc, at, and various other things where you're referring to values in a data frame using things like the index, they use the square brackets, but the difference is that you have some name of a function or name of something before the square brackets, but it's still referring to a way to basically access values from your data frame using an index. So I don't know whether that's 100% consistent, but I think in terms of the syntax, that might be one thing it's helpful to think about, is at least for some of these, I think they call them accessors in the Pandas terminology, ways in which you can access values from your data frame. You're still using the square brackets, which is kind of like what you're doing with the Python list when you use an index value. So that might be something that's helpful. Otherwise, I think the biggest thing that's going to help is just practicing and using Pandas more to get more familiar with the syntax. The other comment here it's piqued my curiosity a little bit. The structure of the site could be improved, so I'm kind of curious. I don't know whoever. I mean, I can like close my eyes or whatever, but I would like to know what the sort of suggestion for the improvement to the site structure would be, because that's something that's would be quite useful to know. So I don't know if someone is willing to share what they were meaning when they said like the structure of the site could be improved. But you could also expand in your comment here if you want to remain anonymous and just let me know, or send a message, post something in the general channel in Slack. If you have comments like things like, oh, it would be better if we organized the lessons this way, or could this thing be on the web page in some place, or whatever, those kind of comments are very useful because, of course, ultimately, what we're concerned with is making sure that you can find the information you need when you need it and as easily as possible. So things like the web page organization. I mean, at least if you're referring to our main course page here, for example, I mean, we're restricted in some sense in the layout of the page, but there are some things that we can also reorganize. So the content can be easily reorganized. Some of the elements of how the page is laid out are a little bit less flexible, but you're more than welcome to share comments in Slack if you want, or or somehow, you can also put something more here in the Pressimo poll, which would be anonymous, of course. Um, but yeah. Any other comments or concerns about the first taste of pandas that we had last week? So just like informally, out of the group that's here, how many of you still are working with your partners in the exercises? Okay, very good. I think that'll be something that's beneficial for this week as well. And maybe that's as good a place as any to segue to today's lesson. So here we are in lesson number 6, and I'll just hide the table of contents stuff. We're going to continue this week with pandas, and we're going to, I think, maybe take a step further in terms of what we can do with pandas this week, and actually end up in the lesson doing some kind of batch processing of several different data files and applying some other things we didn't see last week in pandas, like how to use functions to calculate values inside of a data frame in pandas, and also how to aggregate data. So we're going to be working with an example of climate data where we have multiple measurements per day, and we're going to end up aggregating those measurements into average values for the month. So we'll learn how to do that in today's lesson. So yeah, the goals in terms of the lesson just in general, of course, is that we're going to learn more about how to analyze data with pandas and how to repeat an analysis workflow for several input files. So that's the kind of batch processing part of this. If you have many data files that have the same format and you need to do the same operation in them, we'll go through an example of how to do that today. And this is a very useful thing. I mean, probably this is one of the strengths of why you would do this using something like Python and pandas rather than just doing it in Excel, is if you have dozens of files to go through, you write your script one time and your script can process and do the same operations many times over. And the second part of the lesson today is going to focus a little bit on errors and debugging. So, if you've been struggling in some cases to try to interpret some of the error messages you get when something goes wrong in your Jupyter notebooks, we'll talk a little bit about the different types of common error messages and how to interpret them, as well as some ideas for how to more efficiently debug your code when things are not working properly. So that's kind of where we're headed. And if you haven't already, it would be good to launch your CSC Notebooks instance, as we're going to go first into our lesson about our second part of the data analysis using pandas. So I already have my CSC Notebooks environment open here. I'll try to make this a bit bigger so that maybe that's reasonably visible like that. So yeah, if you're in here, just as a reminder, we're going to have to go first to the My Work folder and then into the Notebooks directory. And there, if you go to the Git plugin, you can pull down the lesson materials for lesson number 6. Maybe next year we'll try to figure out a clever way to automatically do this, but at least for right now, that's the way that we have to do things currently. So I'm going to go to the Git plugin, and what you'll see after some short amount of time when you're in here is that you should get the little orange circle that shows up saying that there are new files to pull down. And if you haven't made any commits, you should be able to click that and successfully pull down the files for lesson number 6. So yeah, why don't we all do that now? And if anyone's having trouble, maybe let me know. We had a couple issues last week with difficulties pulling changes because of commits that were made. But yeah, if you're having a problem, maybe just raise your hand so I can assist. Okay, I'm not seeing anything at the moment. If something comes up, please feel free to interrupt me, and I'm happy to help out. I would much rather have it be the case that you have the notebook files and everything's working than worry too much about being interrupted. So I don't really care about that part. I mostly want to make sure you have the files you need for today's lesson. So yeah, we're here in the lesson 6 directory inside notebooks, and our first notebook we're going to open is this one, advanced data processing using pandas or something like that. I can't see the full title of it, but I'm going to hide the file navigation thing and close the launcher tab, and yeah, here we are. I guess, is that big enough font size in the back? I can't remember how far I had zoomed in last week. Is that okay? Or would you like it one bigger? Yeah, good? All right. So yeah, if it's too small or whatever, just please let me know. So our motivation for today's lesson is here. Since I'm zoomed in pretty closely, it's a bit hard to see both the figure and the text at the same time. But a few years ago in April of 2019, we had one of the warmest Aprils on record in many parts of the world. And you can see specifically here in parts of Northern Europe that this was quite a bit warmer than average temperatures. I can't remember exactly what the temperature anomaly is, but it's something like maybe more than 5 degrees C warmer than average in that year. And our task and sort of what we're going to end up doing in today's lesson is to take a look at weather data from weather observation stations here in Finland. In total, we'll look at 15 weather stations, and we're going to go through and calculate what the average temperature was in the month of April over the record time that each of those stations has, and then sort things to see whether or not April of 2019 was in fact the warmest April on record at those different weather stations, because of course there is some variation across the country in terms of whether the temperatures were hotter than any time in previous records or not. But globally, this was a hot April, so it makes for a nice data set for us to be able to explore a little bit and to apply our tools that we've learned in pandas to a larger set of data. So at least according to the information that I found, 13 locations in Finland had their warmest April in April of 2019. And I didn't poll every station from Finland. I think that would provide us with a data set that's perhaps too big for us to analyze efficiently during the class time, but we'll take a look at 15 stations and see of those how many had the hottest April occur in 2019. Globally, though, it was quite warm just in general in that month. As you can see, for instance, here, this information we first put up on the course page, I think, back in 2019, but I'm fairly sure this is still true, that the sort of second warmest April on record is still April of 2019. So in order for us to be able to do this, we need to do a little bit more than what we did with pandas last week. And so we're going to learn first how to rename columns. So when you read in a data file, you know that you get these column headers that come in with the data file based on information that's there. Sometimes the names of those things don't really make sense, so we can rename them to make it more intuitive for us to work with. Then we're going to go through some examples of how to go through and do calculations either row by row in a data frame to use a function, for example, or to use a function to calculate values for an entire column in a data frame at once, which is a little bit more efficient way to do it, but it's good to start with the example that is more like working with a for loop. Then we'll do our data aggregation, which again for us means we're going to take temperature records that are multiple times a day and try to calculate from those a monthly average. And then in the end, we'll basically work our way through doing this process from start to finish during most of the lesson. And then at the end, we'll go through an example of how to basically repeat what we've done, but for 15 data files rather than a single data file. The data that we're working with this week is data from the US National Oceanographic and Atmospheric Administration, same database that we used for last week's lesson, although we're using more weather stations this time, and I think our data format is also a little bit different than what we worked with last week. If you happen to be working with the Jupyter Lab that's installed on your own computer and you're not using the CSC notebooks, you need to follow the steps here for how to download the data. If you're using the CSC notebooks, you don't need to do this. And I hope you're not using Binder in this lesson because it's really not going to work well. But yeah, is there anyone who's using using Jupyter Lab like installed with Conda on their own computer, or are you all using CSC notebooks? Okay. Then yeah, if need be, you can find instructions for how to download the data here. And if later you want to install Jupyter on your own computer and you want to do this lesson again, you can find information about how to download the data. But we can skip all of that, which we couldn't skip last year and took quite a bit of time to go through. So I'm happy to say that we don't need to do that this year. What we have here in our data set is described in a few different files here. So when you download weather data from this database, you're provided with several metadata files that basically describe the data sets that you're working with. So if I click on one of these, for example, the first one that shows up here, I don't know if there's a way I can make this not wrap the line, gives an overview of all the weather stations that we've got data from. So you can see here the list of locations where, or the station names, I guess. I don't think there's actually, okay, yeah, is also geographic information that's given for those locations. But you have here basically the set of weather stations that we're working with, and I think we have fairly good coverage in terms of like spatially spread across the country. I guess we don't have like Kilpisjärvi, but otherwise we do go into Lapland in some cases. So there's fairly good data distribution, and you can find that information about which stations we have, for example, there. There's also information about the weather observations. So there's another data file here. And again, I need to turn off the wrapping. What this does is it tells you for each station, so for instance in Sodankylä, it tells you in a given year how many records there are for each one of the months, I believe it is. So I think there should be 12 of these columns. And so for instance in 1917, you can see that there were 93 measurements a day that were recorded at that station. And for most of the stations, as you go forward in time, you'll see that number increasing. So for instance, by 2019, at the same station, there were 744 records per month, so 744 temperature measurements recorded per month in the month of January, for example. So this, again, describes the data that we're working with, gives you a sense of how many observations we have in total. And then finally, there is a data description text file here that basically tells you about what each one of the columns refers to. So you'll find things like the U.S. Air Force catalog station number is what this USAF column would refer to. And then this year, mo, da, Herman column is the year, month, day, hour, minute for the recording of each one of the observations. So you can find again here, if you're curious about what any of the columns are, a description of the data that we're working with, and that's good to have. So that is provided for you, and you're of course welcome to look through those files if you'd like. The data we're working with itself looks something like this. Unfortunately, it's wrapped the column here, so it's a little bit kind of confusing. I don't know if there's an easy way to fix that in the view that we have here in the notebook itself. I don't think we have the same option to not wrap lines. But what you can see overall is that we have quite a few different columns, some of which we may or may not need to use. And you can see that the columns have sort of a fixed width. So for instance here, the date column is always going to have the same number of characters in it. And just like we saw in one of the earlier examples, I think in the exercise for last week, we have asterisks or the star characters here that are used to indicate missing measurements. So rather than being comma separated or something like that, these have stars to indicate anything that's missing in the data file. So that's, again, the sort of data format that we're looking at. We could go find one of the data files and look at that, but I think this kind of gives you enough of a picture, and we can just go ahead and start into reading in our data at this point. So to do that, of course, we have to import pandas because that's what we're going to be using. So let's start by importing pandas as PD, sort of standard operating procedure. And yeah, at this point, we can have a quick look at this data file. Well, we kind of see the heading part of it up here already, so I'm not going to do that just because it could cause some trouble with which directory we're working in. But the data file we're going to be working with is from Tampere-Pirkkala station, and you'll see, as we already have pointed out, or as I've already pointed out, that what's happening here in the data file is that we have different numbers of spaces that are separating some of the columns. So you can see, for instance, in some cases, there's 3 spaces here, there's a single space here. It's white space is what they call this when you have sort of gaps between the characters. And the thing is, it's not consistent. It's not like it's always one space. So we can't just say like, okay, use a space as the delimiter. Or, you know, it's not like it's a comma or some other character that's something we can use to say that that's what separates the columns in our data file. So in this case, we're going to use a little bit different approach. We're going to use this delim whitespace equals true option when we read in the data file. And what this means is that it's just saying that there's some number of spaces that's used to separate the columns in the data file. You can also use this sep thing like what we did last week, and then you put in this like /s plus. Both of these will do more or less the same thing, but the delim whitespace equals true, I think, is a little bit more clear for what you're doing. The /s would be indicating a space character, and then the plus is indicating that there's more than, or potentially more than one. But I think what we're going to do is we'll do the delim whitespace equals true, which will function nicely for our purposes here. And the other thing is, like we saw in the exercise last week, we have this different number of asterisks that are being used to indicate no data values. So again, we have to put in this NA values equals star, 2 star, 3 star, 4 star, 5 star, 6 star list to indicate that anything that matches those values will be treated as missing data. Okay, so one other thing to note here is our data location is actually in the shared directory. This is a little bit dangerous, but let's do it. So if we go here to the file browser and you just click on the little folder that takes you back to the kind of base directory where we're working, you'll see in there is a directory called shared, or a folder called shared. If you double click on that, there is now a directory called data that wasn't there before, but I think it should be the case that you all can see the data directory. And inside there's a folder called L6, and inside there are all of our data files as well as the metadata. So these kind of descriptive files that we already looked at just a moment ago. I think what we're looking at is the file called 029440. This is why you need the metadata, because it's not obvious that that's referring to Tampere. But let's go, if we go to 029440 and just double click on that one, it may take a moment to load because the file is fairly big. I don't remember how many lines are in here, but we'll see that in a moment. So it's going to take a second for this to open, which it will hopefully do at some point. But I think it's something like 700,000 lines long, so there's quite a bit of data there. And this, again, is the reason why we're using pandas and not another tool to deal with this, because it's a big data file. I suppose, as we wait, the point here is that all of these different data files are going to have the same format. They'll have different numbers of observations for each one. some of them. I probably could have chosen like one that had fewer observations, which would have opened faster, but there we go. Now I'm just going to go to view and turn off the wrap words so that now things are looking a little bit more easy to read. But you can see, for instance, here, all of the different column names that we had that we've already seen for this one data file. And if I grab the little whatever slider thing here on the right and go down to the bottom, in this case, yes, it looks like we have 757,984 measured temperatures, and in some cases wind speeds, and I think even in some of these cases, I think the text that's here might be somehow referring to the weather conditions. But you can see there's a lot of data here, and this is what we're going to be working with. So the important thing before continuing is that if you did follow the path to go take a look at this data file, that you click on the folder, like the base folder again, and go back into the directory where we're working, because otherwise you may have some issues that you might get some messages that you're not allowed to write files to the shared directory, for example. So sometimes Jupyter gets a little bit fussy if you're in there and it can't write files. So we're going to go back to my work, to notebooks, and to L6 before continuing. So just kind of back to where we were. So we've had a look at the data file. You've got some idea of what we're working with. We've now imported things into pandas, and I have set things up so that all you have to do is run the cell here, which will define the file path, and this is the absolute file path to find the data file we're working with. So this should work regardless of what directory you're working in, and you can just run that cell to define the file path. You'll see that it points to our shared /data/L6, and then here's our file name that we want to work with there. And the cell below it we can use to read in the data file, just like we did last week. You can see FP is going to give the path to the file, and then we're using this delim white space equals true and the NA values thing like we did before. So you can just run that cell as well to read in the data file. You can ignore the error message that you get here. That doesn't really matter for our purposes, and we'll actually do something a little bit different in just a second to read the data file in a different way. But this is just a warning, and one thing maybe worth noting to you is that there is a distinction between a warning and an error message in many different coding, like programming languages and just using a computer in general. So warnings are normally not fatal. So this warning is just telling us something about the data that's here in the file, but it doesn't mean that the file was not read. It read in the file. It just says, hey, there's something weird here in some of the columns. They seem to have different mixtures of data than in other columns. An error message, if we got one, would mean that the file was not able to be read properly. So, it's one thing, we'll talk about errors later in the lesson today, but just pay attention. When you get a warning message, most of the time you can ignore it because it will, it might be telling you something useful, but it's not preventing you from continuing on, whereas an error message is going to be kind of, you need to fix something before you can continue. But we've read in the file, and we can now, I think we read it into a variable called data. So we should be able to, for instance, do data.head and take a look at what the first 5 rows of our file that we've read in look like. And if you do that, you'll see the different column names that we've already seen for the data file format. So that looks kind of good. And you'll see that there are other variety of values that are listed in here. Lots of missing data because in many cases, I don't know what all these column headings mean. We'd have to go and look in the data file. This probably is something about precipitation and things like that. But there's more columns here than we actually need. So we don't need all 33 columns for the data that we're going to work with because we want to focus on temperature. So like the wind speed doesn't matter for us. And if we wanted to take a look just by typing data.columns, you can get the full list of the columns. It's kind of compressed here in the view of the data frame. But here are all the different columns. And really the things that we need in this case are going to be the date, the temperature, and maybe some of the other things that are related to temperature, but we don't need a lot of this like whatever MW, MW.1, MW.2, all that stuff is unnecessary for our purposes. And frankly, when you're working with your data in a data frame, you want to work with the data you need. There's no point in keeping around all this extra junk that we're never going to use. So with that, we can read the data file in once again. And again, you don't have to type anything into this cell. I sort of don't feel like it's the most useful way to use our time to have you type in like multiple lines of things to read a data file in the lesson. But the thing that's different here is we're going to add in this use calls parameter. And I think we did this in the lesson, or did we do it in the exercise this past week? I think we've seen use calls once before, right? Yeah. So all that's going to do is just tell us, hey, only take these columns. We don't need all of the stuff that's there. And frankly, like we don't actually need this dir or SPD or gust. That has to do with the wind direction, wind speed, and the gustiness of the wind. We don't need that for what we're going to do, but we're going to bring those in just because we can. And we're going to drop out then most of the other columns we don't need. So if you run this cell, it will both read in the data again, overwriting what was there as the variable called data, and then it will print out the first 5 lines after reading in the data file. And you should now see that we're dealing with something that's a little bit more manageable. So we still have our date, we have our temperature information, and the max and min is mostly missing, but at least back in 1906 for the data file we have, but we'll see that's present in some of the other parts. So everything looks good. We've now read the data file in properly. We've converted all the star characters into NaN values, which is the desired behavior in this case. And now we can move on to our first step of processing the data. In this case, what we are going to do is to do some renaming of the columns that are here to make them a little bit more intuitive to work with. So just as a reminder, if you type data.columns, you'll again see the names of the columns that are here in our data frame. So we have this USAF, your, mo, da, her, for the date, dir, and whatever. These other things that we're going to need. And there's a couple different things that we need to consider here. One is that in order to do this renaming operation, we're going to use a new data structure we haven't seen yet in Python called a dictionary. Dictionaries turn out to be really cool and useful data structure. And for us, basically, we're going to use this dictionary as a way to link an existing column name to the new name that we want to use for that column instead. So a dictionary in Python is defined using a key and a value pair, so that like when you look for what this key is, it returns to you the value that's associated with that. We'll see how this works in just a second. But yeah, we can start basically by creating our dictionary. So we can make a dictionary here that says new underscore names. This will be what we can use for our new column names. And then we'll say it's equal to, and then we have curly braces. So this is something we haven't used that often. Maybe we've been using it, I guess, only with F strings to this point. But yeah, now this is what indicates that we're creating a Python dictionary, is the kind of enclosing it in curly braces. Then we take one of our existing column names, like our lovely your, mo, da, Herman column. So your, mo, da, hour, minute. That's going to be the key that we're going to use as our first entry in this dictionary. And the idea here is that if you put this colon character, any place when it sees the name of the column called this, it's going to then replace it with another thing, which we'll just call time. We could call it date, we could call it date and time or whatever, but we'll just call it time for simplicity here. So the column that's here called this thing will now be renamed to be time. We haven't actually told pandas yet to rename it, but we're just creating the dictionary that will allow us to do that. And then we can have another key and value pair because we also want to rename the column that's called SPD. So we can say SPD colon, and we'll call that one speed. I think in the case of this data file format, the headings were trying to be used that they would be the same length as the data that would be filling those headings, filled in under those headings. So SPD instead of speed, like speed is not that much longer, but you only need 3 numbers to represent the wind speed typically. So that's what you get. And then Gus, we will rename to be called Gust. So just as a, actually let's get this thing out of here so we can see more. Just as a reminder, basically we have some character string here, a colon, and then another character string, and each one of these sort of first things would be called our key, and the second thing would be the value, and then you just separate these key value pairs with commas when you make this dictionary. So that will create our way in which we can rename the columns, and then the next step is going to, well, let's first just see what this looks like when we print it out to the screen. So I'm just going to type in the name new names here and run the cell. So you can see, for instance, here now that you get this output with these curly braces here, this is indicating that this is a Python dictionary, and you can see also this key value pair, and they're listed sort of one after another like that. If we check the data type of our new underscore names variable, you can see that that comes back as a type dict, which in this case is indicating it's a Python dictionary. There are lots of ways, as I've mentioned, to use these dictionaries. This is just one example that we're going to use for renaming columns, but they're actually pretty functional for many different kinds of operations. So we won't, I don't think, see them in any other context than renaming columns, but you may see them in other Python courses, and certainly if you go looking around online for example codes, you'll find these dictionaries around, often for things like kind of swapping out values or giving a different name to something. So we created our dictionary here called new names, and now we can actually go through the next step, which is to rename the columns. So we'll say data equals data.rename. So we're going to take our existing data frame and say it equals data.rename, and then the columns equals new underscore names. So this is going to do an operation within pandas. So data frames have this method called rename, and then we give the parameter here called columns, and then a dictionary that should contain the existing column name, and then that would be the key, and the value would be then the name that you want to have that column have instead. And after running this cell, we're going to have the data.columns values printed out to the screen so we can see what our column names are now. That's the typo on my part. That should be data, not date.rename, sorry. So if I run that, again, fixing that little minor typographical error, you can see now that the second column is now called time, our SPD column is now called speed, and our gust column is now called gust. So in the past, in the exercise or in this lesson, we had been working with an example of a, maybe it was a 2017 or something like that. There was a big storm during the summer that blew down a whole bunch of trees, and we had been looking at like weather station data from the Helsinki-Malmi airport, and found like there's 1 hour of wind speed that was like twice the velocity of any other wind speed record in the history of that station, and that happened to be when the storm hit. So that's why we were working with these columns like dir, speed, and gust. But for our purposes, we can still just get some practice renaming things this way. And in fact, you can now get your own practice with an opportunity to check your understanding. in this situation, what we're going to do is we're going to be converting our temperatures eventually from temperatures in Fahrenheit to temperatures in Celsius. So to avoid the possible confusion of what the temp column is referring to, we can rename temp to be called temp_F. And also we can rename this USAF column to be called station number. And that is your task now. So since we've seen an example of how to do this renaming operation, let's rename a couple other columns following the example we saw above. So in this case, you want to rename the column called temp to be called temp_F, and the column called USAF to be called station number. And once you're done with that, we will continue. Let's just go through the example here of how to do this once again. So we can make another dictionary first for renaming columns, which in this case can have the same name, doesn't matter. We'll call it new names. Again, since it's a dictionary, we're going to put this in the curly braces. And we know that we want temp, or the column called temp, in this case to be renamed to temp_F. So that's our first entry in the dictionary. So we have the key, in this case, temp, and the value temp_F, and those are both in quotation marks because they are character strings. Then comma. The other one we want to rename is called USAF. At the moment, we want it to be called station_number, or station ID. Doesn't really matter. We're not going to work with it after this, but something that makes a little bit more sense than USAF, which is kind of not necessarily intuitive. So that's our dictionary. We have, again, two key and value pairs here. Then to rename the columns, we're going to do data equals data.rename, just like we did before, rename. And then columns equals new_name. So it's exactly the same thing what we did before. The difference is here that we just changed the dictionary that we're using to do that, so that we'll rename two different columns. And if you run this, you should hopefully see that now the first column that we have is called station number, and the column that we had for temperature before is now called temp_F, which will be helpful for us to remember that those are temperatures in degrees Fahrenheit, not Celsius. All right. So we've renamed some columns. Let's have a look at this point at some of the properties of the data that we're working with. So we can check first off our number of rows and columns that we have using data.shape like we did last week. Data.shape is going to give us an attribute of this data frame, in this case showing that we have 757,983 rows. So our data file, I think, was 757,984 lines long, and that's meaning that we have one line for the headings, and then the rest of it are data values, which we can see here. And then we have 8 columns, and I think we could easily count that up. So 1, 2, 3, 4, 5, 6, 7, 8. Sure enough, it looks like the information we have is correct. So we're working with a fairly large amount of data in this case. Again, you can do data.head to check out the first 5 rows of the data file, or data.tail to check out the last 5 rows of the data file. We haven't talked about the description of the dates yet. I think that's coming up here in just a moment, but the format here is that the first 4 numbers in the time column are going to be the year. So we have data starting from 1906 and going up through, I guess it would have been October, 1st of October on 2019 as our last thing that's recorded in this data file. So I didn't grab new data for this year, but yeah, that's what we have. And so that also looks fine. Of course, we've already seen that we can type data.columns to see the list of the names of the columns that we have in our data frame. Nothing really particularly interesting there, I wouldn't say. Oops, I guess what I'm supposed to do here is actually the data type of the columns, not the names of the columns. So let's do that with data.dtypes. Sorry, my mistake. I should probably read this before I type things. So this will tell us about the data types we have in the different columns. So we have two columns that contain integer values, the station number and time. So those are going to be whole number values. And well, here's our station number. That's a whole number. And there is our time, which is also a whole number. And then we have floating point values for the other columns. They're decimal values for all of the other columns. And if we want to get some overview here of the sort of statistics, we can use this data.describe method. And if you run that, you'll get a bunch of output here showing things like the number of observations in each one of the columns, the mean value, standard deviation, et cetera, et cetera. Some of these are meaningful, some of them are not. Obviously, for the station number column, the mean value is the station number itself because it's exactly the same for all of the rows, which is also why the standard deviation is 0 because it doesn't deviate. But for some of the other columns, some of the things might actually make some sense, like figuring out what the mean wind velocity is and its standard deviation might tell you something meaningful. Mean temperature, for example, could be also something interesting to consider. But one thing that you can note already is that when you look at these values for count, for example, for the station number, we have 757,983. That's the total number of lines that we have in our file, which makes sense. But then for other things like gust, you can see there's only 19,906 observations. There's a lot of missing data in that column. In some of the other columns, you'll see the same kind of thing for max and min, for example, that there's quite a bit of missing data. So this is a nice way that when you load it in a larger data file like this, the data.describe approach helps you just to kind of get a quick look at like how much data is actually missing, because in some cases it may change what you want to try to do with the data file. All right, let's now move to our next topic, which is using functions in our data frame. Yeah. That's a good question. I think, to be honest, I'm not certain I know, but my guess is what's happening here, and the same reason that like the station number gets converted to being decimal values, is that it's doing some kind of mathematical operation here. Like, I don't know why for count it doesn't give you an integer value, because it seems like that would be something that there's either a value there or there's not, so it should always be a whole number, I would think. You can't have like half a row of value. I don't know why it's doing it like that. My guess here for the time column, for example, would be that once the numbers get above a certain size, it must have some rule that says like if the number is bigger than this, because I think the width of these columns is fixed, it might say like, okay, represent that as scientific notation because the column can't be wide enough to show the whole number. It's a bit of speculation on my part, but that's my guess for why it's doing that. Is it's just trying to say like, okay, well, we still want to show as much of the number as we can, but we can't show the whole thing because the column's not wide enough. And my guess is that this is a sort of like template that has a fixed width for each of the column values. But yeah, there's some things in here that like I don't know why the count column wouldn't be an integer number. Like that doesn't make much sense to me. Why you would want to have like 0.0 after most of these values, because that just seems like wasted. I don't know. That's a weird weird decision, but for most of the other things, like anytime you're doing an operation where there's like division involved, you almost always get a floating point number back. So for some of them, like calculating mean, even if you divide by the same number of observations that you have, then the mean value is going to still return a floating point thing because it's the division operation. Ages ago, when Python 2 was the thing, integer division didn't return floating point numbers, so then there could be like nasty things that would happen, like if you divided, if you took 3 divided by 2 as whole numbers, for example, you would get the answer 1 back, because it didn't actually give you the decimal value, it just truncated it as like, okay, if you do integer division, 1.5 gets truncated to being 1. So that would lead to problems that were, in some cases, very difficult to track down. But yeah, Python 3 now does division so that everything is floating point. But yes, good question. Thanks. And for the rest of you, feel free if you have questions like that to interrupt me anytime. I'm always happy to expand on what we're looking at. But yeah, our task now is to apply and use functions to, in this case, convert our temperature data from temperature in degrees Fahrenheit to temperature in degrees Celsius, because that's what we're going to want to work with. That's more familiar to us in terms of our day-to-day considerations of temperature. And frankly, the vast majority of the inhabitants of the Earth are using that temperature scale and not degrees Fahrenheit, so let's do the thing that makes sense. First off, to do this, we're going to define a function. You might have seen this function before. It's probably the third or fourth time it's come up in the course. So this is our, we can welcome back the far to Celsius function. For converting temperatures from degrees Fahrenheit to degrees Celsius, we don't need to talk about how to create a function and any of that other stuff. We simply need to run this cell to make this function so that it's available for use in our application here. So you can just run the cell with this function in it, and that will store the function in memory so that we can use it after that. If we want to make sure that things are working, that our far to Celsius function's working properly, we can start by doing a temperature conversion of some known value. So if we just take our function far to Celsius and give it a value of 32 degrees, that's the temperature at which water freezes in degrees Fahrenheit. And if you run that cell, you'll see that the equivalent Celsius temperature is 0.0, which looks to be correct. If you want, you could also put in 212 degrees instead, and what you'll find is a temperature of 100, because 212 is the always intuitive temperature at which water boils on the Fahrenheit temperature scale. And one other thing we can do here is let's just again remind ourselves of what we're working with in terms of our data by doing this data.head operation, so that will show us what our data file looks like, just as a reminder. So the first way in which we're going to do this kind of temperature operation, this kind of calculation, is using something called iter rows. The name, I suppose, is probably somewhat intuitive in that we're going to be iterating over the rows in our data frame. And in this case, we're going to be using a for loop to do that. So it's kind of like what we would have done earlier, that we'd have a for loop and we just go through row by row and calculate, here's the temperature in Fahrenheit on this row. Let's use our function to get the temperature in Celsius, and then we fill in that value in our data frame. So you have an example here, and again, I think this is basically just something that you can run without needing to type anything into this cell. But just a couple things to highlight before we run it. So we have a for statement that's indicating that we're having a for loop. The data.iterRows method is going to return both the index of the row that we're at and all the values from that row of the data frame. So this is why it's like has two values separated by commas here, is because this iter rows thing is going to both say, here's the index value for this row, and then here's all the data from that row. And so when we run this, we're going to first print out what the index value is, and then we're going to print out temp_f, which is going to be the value from the temp_f column in the row that we have in this case. So that's what's coming here. And then we have a break statement. We haven't seen break before. But what happens when you encounter the break statement inside a for loop is it basically stops going through the for loop. So this allows us basically to do this operation one time and then stop and see how things are working. So rather than having to go through all of the lines of the file and print out for whatever 750,000 print statements, or two times that actually, we can just take a look at one row and see what we get. So we see, for instance, in the first row, the index is 0. That makes sense. If we scroll back up here, that our first index for row number 1 in our data file is index 0. And we see the value of temp_f in that row. So the thing that we get here when we look in the rows temp_f value is 27.0, which again, if you scroll back up here, fits with what we see in the data frame. So this iter_rows method is allowing us, or will allow us, to go sort of step by step for each line of the data file and do something with the data on that line. And just for testing purposes, we include this thing about breaking the loop. Okay, let's now do this to do a temperature conversion. So first we can start by creating a new column in our data frame. So our data frame is called data. We're going to make a new column here called temp C, and we can initialize it with values of all 0. Strictly speaking, again, we probably don't need to do this, but I think when using the iter_rows approach, it kind of makes sense to do it because you're going to basically create the column, then you're going to go through and fill in values at the locations in the column, so that's what we want to do. Again, this loop is going to take us through each one of the rows of the data frame, and in this case, when we encounter a value in the row, we're going to take, for example, our temp F value for whatever row we're working with, and then put it inside our far to Celsius function, which will convert the temperature from Fahrenheit to degrees Celsius, and store that in this loop as the variable called Celsius. Then once we have the Celsius value, we can use the data.at method, or sort of, I guess this is an accessor in the pandas terminology, to go to the row of our data frame that's at index IDX, so that should be whatever row we're working with right now, and to the column called temp C, and store our number that we just converted as the value in the temp C column for that row. So I suppose that makes some sense, kind of how things are working in general here. And if you run the cell, it starts going, and you can see the little asterisk that shows up here means it's processing, and it should take maybe 20 to 30 seconds to do this. So 757,000 lines of data frame to go through one by one with this data iter_rows method or approach takes something like 20, maybe 30 seconds. I mentioned that specifically because we're going to see a different approach of how to do this in a moment, and you're going to see that it's a whole lot faster. I mean, this might not seem that bad for the number of rows that we're dealing with, but this is kind of not the fastest way to access and assign values in our data frame. Okay, so it just finished now. I don't know what the actual clock time was on that, but it was probably somewhere in the realm of half a minute. And yeah, we could even slow this down more if we wanted. There's a reminder here about using the data.at, or whatever the .at or .loc approach for accessing values in a data frame. .at is faster than .loc because .at refers to a single specific location, whereas .loc can be used to select ranges of values, so it's a bit slower because it's more flexible in terms of what it can do. But still, I mean, this wasn't super fast the way that this worked. But if we take a look now at our data frame, like just do a little data.head here, you can see that we now have a new column called temp_C. That looks good. And in our temp C column, you can see the values of temperatures that have been converted from degrees Fahrenheit to degrees Celsius. And since the freezing temperature in Fahrenheit is 32 degrees, getting values of temperatures in Celsius that are slightly smaller than that, or smaller than 0, meaning they're below freezing in Celsius, looks to me to be pretty decent. So I think this looks like we've successfully converted our values from Fahrenheit to Celsius. Let's see where we're at here. Yeah, okay. Let's finish with one more thing here before we take a break about applying functions, because this is the faster way and a more efficient way to do the same kind of thing that we just did. And then you'll have an opportunity to have a little check your understanding / break in just a minute. So as it turns out, in pandas, both in data frames and in series, there is a dedicated method called .apply that is designed to use functions to apply them to data you have in the data frame. So rather than looping through row by row by row, you can actually take all of the values from a single column, or actually all of the columns if you wanted to, and convert them using a function rather efficiently. So if we were to say, for example, data, and then we take a look at our temp f column, so let's say temp underscore f, and we were to say dot apply, and then var to Celsius, this will take the values from the data temp f column and apply this function called var to Celsius to those values. Note that when you have the function name in here, you do not have the parentheses after the function. So it's a little bit different syntax than normally using functions, but dot apply is meaning that this should be the name of a function in here. So you could also do like, math.sign or math.square root or whatever it is inside there. In this case, the nice thing about it is that we don't need to read the entire data frame to do this. We just take a single column out of it, which is a very efficient operation, which is why this is a lot faster. And if you run this, for example, you can see it doesn't even take half a second to convert all those temperatures from Fahrenheit to degrees Celsius. So this seems to be making good sense. And so if we wanted to fill in the values to our data frame, all we did here was just calculate what the converted temperatures would be. But if we wanted to fill them in, we could do something like data, and then we'll put this into our temp underscore C column. We're going to overwrite the values that are already there. And then we could take our temp f dot apply, and then the name of our function we want to apply in this case is var to Celsius. So we have here the name of the column that we're going to fill in. It doesn't need to exist before doing this operation, so you could do this, without initializing things, without making the data.tempc or data temp C column first. Then we're going to take the values from the temp f column, apply this var to Celsius function to those values, which will convert temperatures from Fahrenheit to temperatures in degrees Celsius, and then we're going to fill them in to our data frame in the temp C column. Again, if you do that, you'll see that it's very fast, and that is one of the benefits of using this approach, is it's much faster than iterating through row by row, because if you think about it, what we were doing row by row is we basically have to go to our data frame, extract the row of data from the data frame, use one value out of that row, do a calculation, store it, and then go to the next row. And each time you're extracting this, it's slow to take out those single rows one at a time. Whereas here, we take the entire column at once. We basically convert all the temperatures in a single operation, and it's much faster as a result. Just as a demonstration, you could also, and we won't store these values, but you could do this to more than one column at a time if we were to take, for example, our temp, and you don't even need to type this in if you don't want to. Temp F, what is it, min and max? So if we wanted to take those three columns at the same time, you can take a selection of multiple columns from a data frame by putting a Python list in here. So instead of like having a single column name, you add an extra set of the square brackets, and then you can list inside there several column names, and you could do then dot apply, and again var to Celsius. So it's not essential that you do this. We're not storing the output here, but you can see even if you take three columns, it's like super fast to convert those temperatures. It doesn't hurt here that most of these min and max columns are missing data values, so nothing has to be calculated for them. But you can see it's a very efficient way to do this kind of conversion operation or apply and use a function. So I see a lot of yawning and tired looking faces. So that's a very clear indication that at the very least, we need to take a break. And I'm perfectly happy with that. What I would like you to do in the sort of 15 minutes or so that we take for our break time is to both get some fresh air or coffee or food or whatever you want to do, but also convert these columns tempf, min, and max by applying a function like we did above and store them in columns called tempc, minc, and maxc. So it's basically kind of the same operation that we were just doing, but you can store this into 3 columns in the data frame. And we'll continue in about 15 minutes, so a little bit after 10:40.